Welcome back to Epic. I hope you're doing fine. Today, we will talk about the evolution of climate science and, in particular, climate models. So, by now in the course, we have discussed a lot of things. We have discussed what greenhouse gases are, how humans are impacting the environment, and I gave you some very specific examples that a lot of things depend on the region you are in. So, the responses will be different from, say, location A to location B. Now, I don't want you to walk away from this particular lecture thinking that it's all doom and gloom and that we can't do anything to fix the problem, because it's not like that. But it will require a lot of action, and perhaps action that people are not used to taking. It might mean, for example, that some people get more involved in politics, whether they personally run for office or they vote for people who pledge to fight climate change. But it may also mean changing the behavior of your consumption. One example I like to give often is that if I buy some product from China, well, first of all, that product is most likely produced in a dirty factory using dirty conditions. Then it's put on a dirty truck that pollutes and it's transported to an airport. Then it's transported by airplane, which is another polluter. Finally, there's another truck in your country that delivers the package to you. So for us, customers, we just have to click a few buttons really on eBay or on Amazon. But there's a whole process going on there, and we actually don't pay extra for that. So, of course, one solution is perhaps to have a carbon tax, but personally, I'm not very confident it will work, because what happens with carbon tax is that the industry gets taxed, but they pass it on to us, the customers. So in the end, we, the people, pick up the tab. But from what I hear, they can only do so much of that. What happens is that if it becomes more expensive, then people consume less. So that's one thing to consider. Just to give you a bit of a perspective here, this is from the Bureau of Meteorology. This is a map you can find on their website. It's an Australian governmental agency. They made a map of Australia's mean temperatures each year from 1910 to 2019. So we have over 100 years of data here. At least the four hottest years are just in the past decade. So what does it mean for us? Well, obviously, that's not great news. It's not very reassuring. And to make matters worse, according to a Yale survey, the alarmed people, so these are people who are very involved, and a lot of them are activists. Well, 23% of them said they have difficulty understanding news reports about global warming. So even among the people who are most involved, there's still a quarter that fail to understand the topic. And 10% of them said, in general, I don't like to read or hear anything about global warming. Now, this is not very surprising, because a lot of the time you go to, for example, Facebook pages on climate change, and there's a lot of information there. It's very overwhelming. You have to sit down, take your time, and sort everything into respective folders, so to speak. That takes time, that takes effort, and some people are not willing to do that. So before I talk about the scientific consensus, I want to talk about how technology has evolved over time. And this comes from a 2007 paper titled Historical Overview of Climate Change and Science. And here they say that about 95% of all climate change science literature since 1834 was published after 1951. So in a way, yes, it's relatively fresh science. It's new science, but that doesn't mean it is bad, though. Between 1965 and 1995, the number of articles published per year in atmospheric science has tripled. So we have more and more information available, and we also have climate models. As I mentioned much earlier in the course, you have to basically think of it as Lego blocks. First of all, you have huge blocks, and it's really hard to measure things inside. You have to make a lot of approximations. But with technology, these are getting better. So to give you some examples, first one they refer to was called FAR in 1990. And the resolution per block was 500 kilometers. So as you can imagine, this is not fantastic. But just 6 years later, in 96, there was a new model called SAR, and that one had a resolution of 250 kilometers. So basically, we doubled the resolution in just 6 years, which is pretty great. In 2001, there was a model called TAR, and it had a resolution of 180 kilometers, so it's still getting better. And finally, as per the year of that article in 2007, they had a model called AR4, and that one had a resolution of 110 kilometers per block. So technology is getting better. We're able to make better predictions using these climate models. And they gave a few examples of how the climate models operated in the past. So, for example, in the mid 1970s, it was relatively simple, just the sun, pollution, and rain. By the mid 1980s, we added some mountains and clouds. Then we added oceans. Then we added volcanic activity and sulfates. And finally, we added things like entire carbon cycles, aerosols, rivers, and atmospheric chemical composition. Now let's talk about the scientific consensus itself. Basically, what people tend to forget is that a lot of the time in the media, you always hear, 97% of climate scientists agree that climate change is happening. And what they are citing is one particular study, which I will talk about in a second, but there were others before and after. So, a quick summary here. Oreskes in 2004 found 100% agreement among climate scientists that climate change is happening and people are making it worse. Doran in 2009 found 97%. Anderegg in 2010 found 97%. Cook in 2013 found 97%. Verhagen in 2014 found 91%. Stenhouse also in 2014 found 93%. And Carlton in 2015 found 97%. So, regardless of the study you look at, the agreement is always above 90%. That's a pretty high confidence dose there. There's an important distinction to make here because when we say humans are causing climate change, it doesn't literally mean that. Climate change is happening on a natural cycle, but what we're saying is that human activity is making things worse. That's what we mean by climate change these days, anyway. To talk specifically about the 2013 Cook study, humans are definitely causing global warming. And that is the official position of the academies of science of over 80 nations, plus many scientific organizations that study climate science. More specifically, around 95% of active climate researchers actively publishing climate papers endorse the consensus position. So, as I mentioned before, depending on the study, it's usually between 91 and 100% that agree humans are responsible for climate change, with most of their studies finding 97% consensus among publishing climate scientists. Now, I talked about that earlier in the course. It's important who you ask for advice. If you have a toothache, you go to a dentist. If you have an electrical problem, you call an electrician. If you have a computer problem, you don't call a plumber, right? So they also found that the greater the climate expertise amongst those surveyed, then the higher the consensus on human-caused global warming. And to give you some more context here, based on the abstract ratings, they found that over 4,000 scientific papers expressed a position on the cause of global warming, 97.1% of which endorsed humans caused global warming. In the self-ratings, nearly 1,400 papers were rated as taking a position, 97.2% of which endorsed human-caused global warming. And there's a very important point I'd like to make here also. They found that 2/3 of the papers did not express a position in the abstract. So in a scientific paper, the abstract is usually the very first paragraph that you read, okay? It's pretty short, it has to be, because publishers have a word limit, etc. And also, it's expected that every scientist doing climate research knows that humans are responsible for extra global warming. There is no longer a need to state the obvious. For example, if you write an astrophysics paper, You would probably not mention in the abstract that the Earth is a spherical body orbiting the sun. It's very obvious, so we don't have to go over it yet again. So let's use the figure of 97% because it's the most commonly figure used after all. Compared to that, the general public, only about 55% think that climate scientists agree there is a consensus on global warming. And we call that the consensus gap. And the gap in the US depends on which political party you lean towards. For example, if you are more liberal, then in the best case scenario, about 70% of people agree with the scientific perception of climate change. But if people lean more conservative, then that figure is somewhere around 40%. To finish, I will give you some more numbers to think about. In the US, according to an article published on Vox in June of 2020, the percentage of adults who say climate change is affecting local community a great deal or some. Here you find people who lean liberal, about 83% of them agree, but among conservatives, only 37% of them do. When you ask whether human activity contributes to climate change, among liberals, 72% agree, but only 22% of conservatives do. And while there is some agreement sometimes, there are also very strong disagreements. For example, only 8% of Democratic voters think that expanding fossil fuels is a good idea, compared to 35% of Republicans. 91% of Democrats want to develop alternative sources of energy, while only 65% of Republicans do. This graph here shows areas of agreement. For example, both Democrats and Republicans agree that planting a lot of trees to absorb carbon emissions is a good thing. We like trees. Nobody goes to war over a tree, or I would hope not. You provide a tax credit for businesses for developing carbon capture and storage. 92% of Democrats think it's a good idea. 75% of Republicans do. There is still strong agreement here, but the big fights are generally fought over taxation. 94% of Democrats think that taxing corporations based on their carbon emissions is a good idea, but only 46% of Republicans think so. And it's the same distribution for tougher fuel efficiency standards for cars. Don't touch my dirty truck. 77% of Democrats say that government regulations are needed to encourage reliance on renewable energy sources, while only 37% of Republicans do. And here's an interesting table that shows Republican women are a bit more progressive than Republican men. Generally, you can find some common ground, though. For example, 90% of US adults agree that we need more solar panel farms. 83% agree that we need more wind turbine farms. And then the interest drops. People are not very interested in more nuclear power plants. They're not interested in more offshore oil and gas drilling. And they're not particularly fond of hydraulic fracturing. And they're definitely not fond of more coal mining. As I mentioned before, climate change is often a generational problem. People who are older tend to have different priorities, and you find that even among Republicans. Young Republicans embrace change more than older generations. To give you some examples here, only 45% think that more offshore oil and gas drilling is a good idea, compared to 73% from the older generation. 42% say it's a good idea to have more coal mines, compared to 61% from the old generation. I would like to finish by saying that, in general, green ideas are very popular with the US public. I'll give you some numbers here. Renewable energy, there is 74% support. Smart grid technology, 70%. Battery technology, 63%. Electric buses, 62%. Retrofitting buildings, 62%. Electric vans and trucks, 55%. The only thing we do disagree on is meat alternatives, and that only has a 36% support of approval. So, in conclusion, there is a very high percentage of climate scientists that agree that humans are contributing to climate change. But while most climate scientists agree, the same cannot be said of the population. And there it depends on the political spectrum. And finally, climate change is a socio-economic problem and a generational problem. People who are older prefer some older methods, for example, coal mining and offshore oil, while the new generation embraces renewable technologies such as solar, wind, as well as electric vehicles on the road. And generally, all of the ideas have at least 50% of support across the US. So, next time, we will talk about future projections using the RCP index.